what is data integration, why is data integration difficult, and how can we use AI for data integration. In this short video, I'm going to answer those three simple questions. This is the typical data science workflow that you might have seen many times before. What does it tell us? Basically that before we can train machine learning models and use them in production, we have to go through a series of data management steps. And most of those steps deal with data integration. Let's see what that is. Data integration deals with bringing together disparate data sources from one or multiple organizations, or most probably teams within those organizations. After those data sources have been identified, data needs to be ingested, stored, and cleaned. Also, in order to get any meaningful knowledge from the data, we have to describe its semantics and discover the relationships between different data elements. Now, this is the theory. But what happens in practice when people are trying to build a data lake is that they do not really perform these data integration steps. And this is normal. Don't feel guilty. The result is that instead of having this magnificent data lake where data is nicely integrated, cleaned, with descriptions and semantics everywhere, we end up with what we call data swamps. What are data swamps? Basically, those are data lakes in which the data is in a terrible condition. The typical thing we see in the data swamp is that the data is simply dumped in a distributed file system and left to rot in there. But you may ask me, why do we end up with data swamps instead of beautiful data lakes like the one we see in the picture? Well, there's a lot of reasons. The simple answer to this is that it is really difficult, but I will also give you a longer answer. First, there are technical reasons. Data comes from different databases and platforms. They have different data formats and organizations cannot agree on those. Second, there are logical reasons. Not all teams in an organization have the same definitions about their data. For instance, think of a table called customers. For a bank, customers are the people that hold accounts. But for the team that maintains the IT infrastructure of that bank, the customers are actually the employees in that bank who are using the IT infrastructure. Finally, there are social and political reasons. Convincing people to share their data and convincing them to document them properly is not a technical issue, of course. It is an issue of management, team culture, and work ethics, and we cannot control those. Now, let me show you an example of integration and how it can go wrong. These two tables talk about myself. In fact, the table on the left contains my username and my current IP address within the university network. On the other table, we see my computer name and my email. Imagine that one tasks you with integrating those two tables. This means that you have to see what columns and rows correspond with each other. As a human, it's quite easy. Obviously, the table on the left has a username and IP, which corresponds to the email and machine name on the right. But syntactically, there is absolutely no similarity. If I use any similarity metric, say Levenstein distance, the two tables are really far away from each other. There is absolutely no common information to denote any relation there. The schema does not help either. The column names do not give away any useful information. But how about humans? For you and me, the correspondence is clear. Then it is normal to think that AI can help in this specific problem. So let's see if we can use AI. The problem I outlined a bit earlier is called the schema matching problem or the related dataset discovery problem. It depends on who you talk to. But the fact is that in this problem, we are trying to automatically determine if two columns of two different tables talk about the same real world entities and possibly find if the two tables can be joined together. Now, why join the tables? For example, if you are building a machine learning model that needs more features or more training examples, you can enrich a table with more information from other tables. Traditionally, this problem has been approached as follows. We analyze all the tables in the data lake and we calculate similarity measures. Lots of similarity measures. Such similarity measures are extremely expensive to run and they have a very basic limitation. They do not cover the case of semantic similarity. This means that, for example, a NER and Netherlands might be found in two different tables, But unless we know that NL is short for Netherlands, the syntactic similarity metric would give no results. In fact, we have studied the most commonly used algorithms for schema matching for the last 20 years, and we have written a paper about it. Believe me, the results were not great. So if the existing methods don't work, then what would work? This is a question that we are trying to answer at this very moment in the Eiffel Lab. I will simply show you an approach based on AI which looks promising. We call this approach REMA, and the main idea behind this is to use existing tables and how values are put together in them in order to discover new table relationships. How do we do it? We employ word and graph embeddings in order to discover semantically similar data elements inside the data lake. I will spare you the details, but what I want you to remember is that we visit all the tables, we create a huge graph out of those, and then we create embeddings for those graph nodes, and we are trying to establish similarity between data elements in a dataset simply by comparing their vectors in a given embedding space. You will find more details about this in the paper listed in the slide. At the moment, we have already seen the limitations of embeddings, and we are experimenting with graph neural networks that can learn from examples that we source from humans working in the enterprise. Now to my conclusion. Will AI solve everything in data integration? No, it will not. And to get things straight, data integration cannot be fully automated. And whoever tells you the opposite is either clueless or is lying. Instead, what we believe we should be doing is to focus on methods that use AI, not to replace humans, but to help them by learning from human-provided examples and by reducing the effort of humans in discovering data relationships.